Welcome to all students in design of transmission system. Today we discuss about force analysis. In force analysis, the resultant force acting on the helical gear tooth F can be resolved into the following three components. First, tangential force Ft, radial force Fr and axial force Fa. In tangential force Ft, the tangential force is a useful component of resultant force F and it is responsible for the transmission of torque or power. In radial force Fr, the radial force always tends to separate the two gears. It acts along the radial line through the pitch point and directed toward the center. In tangential component of force acting on the driving gear opposes the rotation of driving gear and assists the rotation of driven gear. Also, in axial force Fa, the axial force is an undesirable component of resultant force F. It acts in an axial direction. When the magnitude of axial component of force acting on two meshing helical gears is equal but opposite in direction. So, in force analysis, the resultant force F acting on the tooth of helical gear. So, Ft is equal to tangential component. Fr is equal to radial component. Fa is equal to axial components. From triangle ABC, Fr is equal to F sin alpha n, BC is equal to F cos alpha n from this diagram. Also, from triangle BDC, Fa is equal to BC sin psi, F that is equal to F cos alpha n sin psi. Therefore, Ft is equal to BC cos psi, that is equal to F cos alpha n cos psi. Dividing Fa and Ft, Fa upon Ft is equal to F cos alpha n sin psi upon F cos alpha n cos psi, that is equal to tan psi. Fa is equal to Ft tan psi from this diagram. So, after this, dividing Fr and Ft, Fr upon Ft is equal to F sin alpha n upon F cos alpha n cos psi, that is equal to tan alpha n upon cos psi. Therefore, Fr is equal to Ft tan alpha n upon cos psi. So, from triangle EDC, tan alpha is equal to Fr upon Ft and tan alpha n is equal to Fr F suffix r upon BC is equal to Fr upon Ft cos psi. So, tan alpha n is equal to Fr upon Ft into cos psi, that is equal to tan alpha into cos psi. Therefore, cos psi is equal to tan alpha n upon tan alpha. Therefore, the tangential component is calculated from the relationship, that is Ft is equal to mt upon d by 2. Therefore, mt is equal to transmitted torque, unit is Newton per mm. D is equal to pitch circle diameter, unit is mm. The following information is required in order to decide the direction of three components. First, which is the driving element, which is the driven element. Is pinion rotating in clockwise or anti-clockwise? What is the hand of helix? It is right-handed or left-handed. So, the directions of tangential and radial components are decided by the same method that is used for spur gear. That is equal to, in first, tangential component Pt. The direction of tangential component for a driving gear is opposite to the direction of rotation. The direction of tangential component for a driven gear is same as the direction of rotation. Second, radial component Pr. The radial component on the pinion acts towards the center of the pinion. The radial component on the gear acts towards the center of the gear. After this, the thrust component PA. The following guidelines can be used to determine the direction of the thrust component. First, select the driving gear from the pair. Second, use right hand for RH helix and left hand for LH helix. Keep the fingers in the direction of rotation of the gear, and the thumb will be indicate the direction of the thrust component for the driving gear. And next is the direction of the thrust component for the driven gear will be opposite to that for the driving gear. So this is the thrust component for the following. The thrust component is very important, and after this there is resultant force F. The resultant force acting on the helical gear tooth is determined by using equation, or it is given by F is equal to root of Ft square plus Fr square plus Fa square. The various combination of parallel helical gears and corresponding direction of axial components are different. In order to find the direction of axial or thrust component of force acting on any helical gear, use the following hand rule for the driving gear. When the driving gear is of right hand type, use of right hand rule, whereas when the driving gear is left hand type, use the left hand rule. In the hand rule, keep the fingers in the direction of rotation of gear, and thumb will indicate the direction of axial or thrust component of force acting on the gear. The various combinations of parallel helical gears and corresponding directions of accelerated component as shown in figure. This is the numerical problem of the helical gear. In next lecture, we discuss about this problem. So, thank you very much all of the students.